Hey guys, welcome to the new NFR playlist video, that is reliability. So most of the people are confused between availability and reliability. Today we would be deep diving into reliability to see what exactly is the difference between availability and reliability, how it is important from a system design perspective. You would be understanding a clear differentiation between availability and reliability, what exactly are the parameters, the metrics using which we track reliability of our systems, how to achieve the reliability. All these things we would be learning in depth in this particular video. So starting with first thing, what is availability? So I have already a dedicated video on availability on my NFR playlist. Please do watch that if you are interested. So availability means what? Uptime. Like it tells me how much time my system is up for the customers to use it. So how does we track the availability of a system? We track it via percentile. Let's say 99%, 99.9%, 99.99%, and so on and so forth. So the more the nines we are having, the more the available the system is, the less the downtime of a system is. Okay, so now system is available means if I am sending a request, I am getting a response, I am not getting any error or something like that. That is what availability means. But now let's go one step deeper. What is reliability? So reliability means system should be available, but system should be correct. Availability plus correctness. What exactly correctness means? So let's take this example. If I am sending 2 plus 2 as the request to the system is sending me 4. That is a reliable system. Assume a case. If I am sending 2 plus 2, once it is sending me 5, another time it is sending me 4, another time it is sending me 22, another time it is sending me 12. Does that mean it is a reliable system? No. Reliable means what? Reliable means I can completely trust that system on the output if I am giving that same input. Assume a case where your account balance is having 1000 rupees, you are doing a transaction, you are debiting 500 rupees. What is the expectation? After that transaction, your account balance should look like 500. What would happen if your account balance is looking as 100 or it is looking as 900? Will you call it as a reliable system? No. That system is available? Yes. Because you are sending a request, you are getting a response, your transaction is happening correct. But what is the reliability means? Reliability means like if I am doing a transaction, if I am expecting that kind of an output, the system should produce that kind of an output. That is what reliability means. So if I just deep dive, you consider this a Venn diagram. So availability is this outer circle where my system should be available, but reliability is the inner circle. Means out of this place, this system is not a reliable system, and only this portion is the reliable. So if my system is available, it doesn't mean it is a reliable system. But if my system is reliable, it means my system is available, because for me to get the correct output, my system should be available. If the system is itself not available, then there is no question of me getting a correct output or a wrong output. So reliability is an inner part of an availability. First the system should be available, and then the system should be reliable so that the customer can rely. Your system should be able to produce the same output on every same input that it is getting every time. So now let's deep dive into metric. What all different metrics are there through which we judge our system is reliable or not? So there are 3. So one is MTBF, then there is MTTR, and then there is error rate. MTBF means mean time between failure. So let's say my system is failing now, then after some time my system is again failure, then after some time my system is again failure. So let's say this is the spike when my system is failing, then again here my system is failing, then again here my system is failing, then again here my system is failing. So you see, this is the time and this is the failure. So your system is failing, but then there is certain interval. So when we take the mean time of these failures, we see like, okay, what is the mean time when 2 failures occur in my system? This would help me to estimate like that how much amount of time my system is prone to fail because of any reason, but my system is prone to fail. So that is a reliability metric. The lesser the better. Like, okay, the lesser the mean time means my system is failing very less often and my system is staying up and serving the request and giving a proper response most of the time. That is what MTBF means. MTTR, mean time to recover. So let's say my system is failing here, and then my system is doing a recovery here, and then my system is doing recovery, and here there is a recovery, and here there is a recovery. So this time that we are calling, so this is a recovery, and this is a failure, and this is the time to recovery. So you see here also recovery is happening here, here and here. So after my system is failing, my system is getting recovered, but what is the duration for my system after failing to get recovered? That duration should be constant, should be less as much as possible every time. That is what I can say like my system is reliable, because now I can tell exactly like, okay, if my system is failing, after how much time my system would be available for functioning to its customer. So this is what MTTR, like mean time to recover. Again, the lesser the better. The third thing is error rate. The number of requests that we are sending, how many requests are successfully executed and how many requests are failing. The lesser the better. The less requests are failing, the less error rate, the better it is an experience for the customer. So again, like this is the third matrix, error rate. So MTBF, mean time between failures, MTTR, mean time to recover, and the third is error rate. Now finally we would be looking into how to ensure our system is reliable. So first thing is redundancy. Redundancy with proper configuration. This is the keyword. With proper configuration is the keyword. Now how this is the keyword. So assume there is a case where there is a master and slave replica. Okay. So let's say this is a master node and this is a slave node. So let's say you are doing a transaction, your account balance is 1000 and you are doing a transaction plus 500. So in master it is looking as 1500. But now there is a replication lag. So it is getting replica. But now there is a lag. And now my server, my slave is still showing 1000. Now this is an update operation. Now let's say you are doing a select. And because this is read, let's say it is going to here. And in the response you are getting 1000. Now are you going to call it as a reliable system? No, it is not a reliable. It is available system. You are getting a response, but it is not a reliable system. So despite we are having a redundancy, that's the reason I said with the proper config. So proper config means strong consistency. For an example, strong consistency means what? If I am having 1500 here, at the same time without any lag, there should be 1500 here. And when customer is querying for select statement, he should get 1500 and not 1000. That is what how I am going to achieve the reliability. So redundancy is not just enough. Redundancy with the proper config with strong consistency is utmost importance if we are saying we want to build a reliable system. Majorly in transactional systems, we want availability plus we want reliability. That's the reason strong consistency is preferred. That's the reason asset properties are preferred, and that is how redundancy is achieved, and that is how reliability is achieved. Then the second thing is graceful degradation. Let's say there are three different microservices are there. I am getting let's say an order service is there, an order service, then an inventory service and a payment service. Let's say I am hitting a request to an order service, and now what would happen is like my order service is calling my inventory and inventory is calling payment service, but let's say my payment service is calling gateway and gateway is not available. Now in that case, it is my responsibility to give correct response to the customer saying like, hey, your order has not been placed, the amount has not been debited, there is some technical issue at our side, please try it back later. That is what I am expecting every time whenever there is a gateway issue or whether there is a payment service or inventory issue. I am expecting that kind of an output that should stay consistently. That is called a graceful degradation. So now let's discuss on the failover mechanisms. Let's say there are multiple pods of order service. There is a load balancer, user center request. Load balancer redirected a request to multiple different pods based on different algorithms. Now out of those multiple pods, let's say there is a high CPU and memory threshold in one of the pods. Now it is giving me a late response, or else it is giving me a flaky response, or else most of my requests are failing. Load balancer has to record this matter, and now the future request, load balancer is not going to send to that particular pod, but it is going to send to healthy pods. This is what one type of a failover mechanism. Like your system is smart enough to identify like which pod is functioning not properly. Do not send the request to them, send it to another pod. Second failover mechanism. In K8s you might have observed, if any pod in the cluster is not working properly, automatically at a K8s level what happens is like that pod is removed from the cluster and the new pod is automatically spinned up. That is the second failover mechanism. Third and part of failover mechanism, circuit breaker design pattern or resiliency, where let's say I am a payment service, I am giving multiple calls to payment gateway, and now I start getting failures from payment gateway. Let's say 429. Let's say due to rate limiting and throttling, they are sending me okay, too many requests, try it after some time. Now I am getting multiple requests, but I know gateway is not in a proper state to serve my request. I would trip that circuit. I would not allow any new request to go to that gateway. I would just accept that there should be a failover mechanism, there should be a fallback mechanism where I would be redirecting and I would be sending some response to the customer saying like, hey, our gateway is down, can you please try after some time. You are doing that job, like as a payment service you are doing that job, but are you hitting payment gateway? No, because you have observed like, okay, that system is not working fine, that system is not in a healthy state, I would not send the request to that particular systems. But then after some time it just opens the circuit and it just sent certain amount of requests to that particular gateway to see whether it is in a healthy state. If yes, then it would start sending the new request to that gateway. If not, then it would keep that circuit in the closed state and it would do not allow any new request should be sent to the gateway. This is what the failover mechanism is. Now let's look into an isolation. So generally it is observed in S3 or in DynamoDB, where let's say Amazon DynamoDB, there are multiple tenants. Let's say there is company A, B and C, three companies are there. all these three companies act as a tenant for the DynamoDB for AWS. Tenant as in nothing but a customer. So these are the three different tenants, three different customers who are using DynamoDB or S3. Now what would happen is, let's say there is a huge load, or there is some incorrect code has been pushed, or something like that has happened with one tenant. Now let's say you are at a company B or a company C. Because of any issue at a company A which is hampering the DynamoDB performance, do you expect same to happen with your service, with your company? No. That's the reason, like, we have a tenant isolation. Like, every tenant is having its own environment. So whatever malfunctioning or anything wrong is going on, it is happening only for that particular tenant. No other tenants are affected. That is what called as an isolation mechanism. These are the four major steps using which you can ensure your system is reliable. And finally, the most important thing is testing. Before anything we are putting it in the prod, we have to ensure like we have done the testing properly. Specifically for reliability, we have to do these two types of testings: chaos testing, load and stress testing. Chaos testing I have already explained in one of my shorts. Chaos testing is nothing but anything can go wrong in the production. There can be like power outages, server crashes, and this and that, whatever can happen basically. In such kind of a situation, how your system would react in the production. We try to replicate that kind of an atmosphere, that kind of the testing in our UAT or in our testing environment to see how reliable our system is. Second is load and stress testing. This is very much important testing that for majority of the NFR you have to do to ensure how much load and stress your system can take. And then let's say your system can take, let's say 2000 requests per second. You have to set an optimal limit, let's say 1500 requests only you should be serving to that particular server, not more than that, to ensure a smooth ride for your customer, a smooth request response, or a smooth facilitation for your customer. This is what about the reliability. If you feel something valuable I have contributed in your arsenal, then please do consider liking this particular video. If you have any feedback, if you have any suggestions, or if you do not agree with me, please feel free to comment, and then please feel free to share this particular video as much as possible, and subscribe to this channel for future such videos.